Hello, everyone. Welcome to Nursing 603 presentation weeks. I will be facilitating the two-group experimental design along with Lillian, my partner, in group 3. So let's get started. Okay, so two-group experimental design involves a treatment or experimental group as well as a control or comparison group. So basically, one group is experiencing the treatment or the intervention being tested, and one group, the control group, is receiving no standard treatment or the standard intervention. Subjects are randomly assigned to either group. There is involvement of pre-testing on the dependent variables, and this occurs in both groups. Post-test is always completed on the dependent variable in both groups as well. So steps in the pre-test, post-test design, subjects are randomly assigned to either group. Pre-testing of the dependent variables does occur. Again, like we've said, the treatment group is administered the treatment, so the independent variable. This is of interest to our hypothesis for the study. And post-test completed on the dependent variable in both control and treatment group. So there is that final assessment at the end. Again, when we are looking at measuring effects of the treatment in the pre-test, post-test control group, this is some of the formulas used down here. So we can see R is the random group assignment, O is our dependent variable, and X is our treatment. So we can see in the treatment group above, that is the one being administered the intervention. Looking at statistical analysis of the pre-test, post-test control group design. This is an ANOVA design, so a simple analysis of variance between the two groups. There are some concerns with the validity of the ANOVA. So major threats to internal validity include maturity, so maturation of the study, history, test influences, instrumentation, regression, and mortality. And these threats are often thought to influence both groups randomly, so controlled through randomization. And I really enjoyed the image on the side, just giving you a little bit of a contrast between reliability and validity to help explain the two differences. So when we're managing validity in the two-group experimental design, the steps to increase validity would be to ensure randomization of the two groups. We need to control the confounding variables or those circumstances or variables that are in the study that we maybe can't see or didn't quite think of, but they are there influencing the data results. And manipulation of the independent variable, which is our variable X, as in our previous formula a few slides ago. So randomization, so ensuring that you are actually randomly assigning to these control groups and there's no bias with that. So it does help control that selection biases as there's systematic differences between the two groups. And increasing the likelihood that differences between groups are related to the treatment. When we're managing validity, we want to make sure that we are managing extraneous and confounding variables. So again, some of those variables and factors that may be anticipated or unanticipated as we carry out the study. These can exist in the environment as well as manipulating the independent variable. So only treating the treatment group. Control group is not treated. So the types of two-group experimental designs, there's the pre-test, post-test design. So again, additional threats may exist to the internal validity of this. So we see at the bottom here, I really liked this image. You see the program participants in the comparison group, so your treatment and control group. You are pre-test measured as your baseline. You are administering the intervention or the treatment to the experimental group. And then both groups are post-tested as well at the end to measure the differences. So an example here that I just added in for your understanding, mortality that may occur after the pre-test is complete may influence results seen in pre-test results, thus causing a bias in these results. Again, in the second type would be the post-test only control group. So simple version of the pre-test, post-test, where we actually don't do the initial test before the intervention or the treatment is administered. So we see X is given to the treatment group, and here is our post-test only. So no pre-test there. So thus the treatment result is the difference between the two post-test scores only. So we're only minusing the difference from the treatment group and the control group. No pre-test data available for this. Statistical analysis is by an ANOVA, so two-group analysis of variance design. It is a simple design in nature. Eliminating the pre-test element of the design decreases the threat to validity experienced with pre-testing sensitivity. We see in some study participants. This does control for maturation, testing, regression, selection, and pre-test, post-test interactions. And mortality does remain a threat to the validity of this design, as said a few slides ago in the pre-test, post-test as well. So here you can see no pre-test in the image at the bottom, just the post-test at the end, and those results are analyzed. And in a covariance design, this is a special type of pre-test, post-test control group, where the pre-test measure is essentially a measurement of the covariates of interest rather than that of the dependent variables. So the covariates, let's recall, is an extraneous variable that may influence the measurement of the dependent variables. So these covariants can potentially impact dependent variables, but not what is being studied. Testing covariate impact on dependent variables allows researchers to control their effect. And the result is, of course, an improved assessment of the treatment effect. And we can see here there is an example on the side. So again, the statistical analysis is the two-group analysis of covariance, so ANCOVA. The advantages are same as post-test design, internal validity present due to the covariates control, and this can be applied to the pre-test, post-test design. And the example here, which I found easy to understand, independent variable, the factor would be your level of education, covariate would be the number of hours spent studying, and your dependent variable, the response, being your test score. Thank you very much for listening. We'll be opening up for questions and discussion this week for the two-group experimental design and the different types of designs within that topic. Thank you so much, and welcoming your feedback.